think you're going to need something to kind of remind you because I'm not here. So you can either like scan that QR code, and I think it would take you YouTube channel or not. I forget what that. You look up my name, and then I'll have it posted though to help. So the first thing, and I'm going to kind of through several examples. So on your, I don't need that. That's my stuff. On your paper, it looks like this. Okay, right here. So A and C. If I was to cut those out, I have to decide: is it a function or not? Okay, if it is a function, then I'll glue it in here. If it's not a function, then I just glue it out here. Does that make sense? Yeah, it's just cut and paste. Is it a function or no? Some of them are super easy. So if you have ordered pairs, like system like this, 3, 1, 4, 8, 0, -2, and 1, 5. Okay, that a function? Yes. Okay, how you tell is you look at all the x values, right? So I'm looking, and I just make sure that none of them are the same. So I would cut this out, and I would paste it in the function area. Are we good with that? And then I'll do another. I might do 2. All right, another one. Let's see. 4, 0. Okay, so is this one a function? Yeah, all you do again is look at your x values. They don't repeat, right? So I'm gonna put that one. I would cut it out. That in the function spot. Okay, and then you'll have a third one, and it may be like that function, huh? It's not. So you would do it in the one that just says this. That basically means it's a function. So we don't glue it in the function circle. We glue it in the other spot. Okay. We don't write just a relation. I would normally write no, it's a function. Okay. Are we good with the ordered pairs? Like y'all should know that. I think that y'all could have done that part. The next 3, so that's like E. D, E, and F are written like a table. I'm going to do one of these because it's basically the same exact thing as this. So D, E, and F, they do a little. I'll just throw some different numbers. Is that a function? So what you would do, it's the same exact thing. Look at the x values. What are my values? Those 4 numbers, right? Do any of those repeat? Yeah, the -2. So that is not a function. So I would say I would glue that in the relation part, not the. Are we okay with that? So we have 3 of these. We have 3 like this that are tables. Then we have pictures. Okay, that's GHI. This is also an easy one that you'll know. So far, you need me to move it. So you'll have A through C are like that. D, E are like that. Okay, and G, H, and C, that D, E, and F. G, H, and I. See how they're all little pictures. Okay, we'll just do vertical line test. So for G. Oh, H-I-J. Sorry, just kidding. 4 of them, you're going to do the vertical line test. Okay. So if I have, that's them. Let's graph, and it looks like this. Is that a function? Yes, so you're going to glue that one, cut it out in the function spot. Because to be a function, it just means if I draw a line at any point, it only passes through at one time. Okay. So you'll have four different pictures. It can pass through it one time. If you draw it and it passes through more than once, it's not a function. Okay? I'll do one more of those. Everybody ready, or not yet? And if you forget any of this, just go to the video. I think I pressed record. I did. All right. So one. I think I see. I'll draw one still. The next, those are the difficult ones. Those are the ones that y'all struggle on. So that's really need to go over. Okay, we're done. Anybody still writing? Okay, so one more graph though before I move to the next part. The last little graph that's drawn for you. Oh, I know what I was gonna do. We kind of did one like this. Okay, if it's like that, is that a function? No, because if I do the vertical line, it's okay. What about right? Not okay. It went through a whole points, so it's not a function because of this part right there. Okay, does that make sense? Because so you'll have one anyway that you'll need to be careful with like that. Then we can do the last part. So your next two I'm gonna look at, these are N and O. I know I skipped K. I'll come back. But N, O. All right. One of you might have something like x equals 3, and the other one is like y equals -1. Do y'all remember what these lines look if I was to draw them? No, maybe not. So remember, one's a horizontal line, one's a vertical line. So I'll draw N, and then I'll come over here. I'll draw O. Oh, I know there's skinny graphs. So let me look at N. If it says x equals 3, that means I go over to x. I go over to 3 x-axis. 1, 2, 3, and I draw a line through it. That is that graph right there. Function? No, because if I drew a vertical line through it, it would go every single one of those points, and that's not good. So that one is not a function. Okay. It's the same thing. I just changed the number. So you have this to go by on Friday. You'll get it. Okay. This is putting a lot of stuff together. What about y equals -1? What kind of line is that? It's not going to be vertical. It's going to be what? Horizontal. That means you go on your y-axis to -1, and you draw all these y values are negative, and that's what that means. Every y value is -1. Does that pass the vertical line? Yes. So yes, it is a function. Okay. So that one's not a function. Yes, it is a function. Do y'all understand this? So it's going to say like n equals 2. Sorry, x equals 2 or something like that. So is x equals 2 a function? No. Y equals 4. Is that a function? Yes. So if it says x equals like that function, if it says y equals a number, it is a function. No matter what number I give you, okay? Because this will always be a vertical line, not a function. This will always be a horizontal line, not. You don't have to draw it or anything. All you're gonna do is cut it out and put it. Is it a function or not? Do we kind of get that? Like if you have these notes to go by, okay. Then we have three left. Are we good so far? Yeah, I think y'all be able to figure it out. Okay, if you're looking at K, everybody to write this down. This is what they have for K, but what we do is solve it for Y for you. Okay, so they have, and this is the exact same problem. The rest of them have just been making up things. So this one I'm doing the exact same. They have Y equals 18. I would like to graph that. I need to solve it for X. I'm going to solve it for Y. Do y'all know how to solve for Y? Do y'all remember that? No? So we're getting to this probably in the next chapter. So I'm just going to tell you what you would do, but you don't have to know it. Letter K. Yeah. This is letter K on your project. So Y equals negative X and a positive 18. Or you could have done 18 minus X. Okay? So this is what K says. Do y'all know how y'all graph? Do y'all remember how to graph? What if you have a graphing calculator? Do y'all know how to graph that? Yeah? So that's what you're going to do on K and L. Okay? L, it already says Y. This is the exact one for L. X squared minus 13. Okay? So this is K, the exact same problem which you're going to type in for K. Into L on Friday, that's what you're going to put in. It's the exact same. So let's just do K together on my calculator, and then I'll let you finish this on Friday. Okay, so I got to turn that off. Hold on. What is Y equal? What is it? Negative X plus 18. Just ignore that Friday and remember, oh, this is what I write. So I'm going to put negative X plus, and then I'm going to graph it. I can't quite see it. I'm going to zoom out. But y'all can just remember this. Okay, does that pass the vertical line test? Okay, so on Friday, K, already know is yes. All right, then L, on that one, you'll just type that one in and see what it looks like. Okay, and do the rest on Friday and see if it's yes or no. Okay, and then I'm going to show you M's picture. Okay, I'm going to do square root. I'll show y'all M's pick. The square root of, y'all for this, that's why I got to figure it out. X minus 1 and negative square root. X minus 1 is 1. Okay. All right, y'all ready? So anyway, this is not at all what this is what theirs looks like on your paper for Friday. You have not learned anything like this. We're near that yet. Okay, so what I'm going to do is solved it for Y. You won't understand that at all. I'm just going to show you the picture. Friday, this is what M looks like. All right, does that a vertical line test? So then y'all would know that answer. And you'll cut it and put it where it goes. All right? L should. Did you graph it?
I did.
See it? Yeah. So, and yeah, that one should. Anyway, that goes through all these. So y'all have something to go by. You'll have to pick, is it a function, is it not? And that'll be good practice for your test. After you finish that, I really don't think that's gonna take y'all class, maybe, just because it takes time to cut, paste, and think through each of them. I'll have your study guide, okay, which I think I said your test will be Tuesday on the C. So study guide we'll go over together Monday, test, okay? And it's 31 questions. I'm betting your test is like 25, all right? Now, I'll go ahead. I know I'm videoing. I'm going to go ahead and keep videoing. because we have several out if they need it. So here is today's stuff. We started it, I think, Monday. And then once we're done, I'll talk to y'all about beta convention. I do need to go over that. Okay, algebra 1. We looked at arithmetic sequences. So a quick review, because we've already done the first problem. So we'll go over it and maybe the second problem if we did it or not. Let's see. -15, -11, -7, -3. It says, what's the pattern? Like, what are you doing to get to the next number? And then are the next two numbers. So what did I do to go from -15 to -11? I added 4. And let me check it each time. If you're not sure, try it out. Let me see. -11 plus 4. -7. Hey, that's right. Let me add 4 again. -3. Hey, that's right. So if I keep adding 4, what do I get next? If I 4, it's 1. If I pressed plus 4 again, what would be my next one? Oh, sorry. I don't know why I said that. Okay, so it's 1, and then if I add 4 again, it's 5. So the next two terms, and then you're going to say you are adding 4. Understand those two answers, or really it's three answers. Plus 4 for adding 4, and then the 1 and the 5. So we remember that from Monday? Okay. The next type of problem, it says, tell whether the sequence is arithmetic. What did I tell y'all it has to be arithmetic? Do y'all remember? You have to subtract. Okay, it's geometric. We learned that in geometry if we're multiplying and dividing. Okay, so now, and we did some like that on Monday. Like, oh, we could tell we were multiplying by 2 on the next two answers. But now we're going to say, is it arithmetic or not? So this one, it goes from 3 to 8 to 13 to 8 to 18. Is this arithmetic? What are we subtracting the same number? Yes. What is it? What are we adding or subtracting? Yeah, we're adding 5. So I would put plus 5, and then I find my next two terms. So I would just add 5, and what do we put? 20, 23, and 28. There we go. And I would say yes, we're adding. Yes means it's arithmetic. And there's my next two terms. I think it said find the next two terms. It said find the common difference. Common difference was 5. It's 5. We were adding 5. Okay. Do I have that needs in? If I have, let's see, 9, 13, and 10. Is that arithmetic? No. What am I adding here? What am I adding here? And 4. So am I adding the same thing every time? So your answer would just be no, because you can't say what you're adding. There's no common difference. Okay. Let me see if I have one more type of. I think there's one more that I was going to go over today. But goodness, where is it? Yeah, I have one more to do today. Okay. Nobody likes. All right, then the next thing, the last for today, we're going to learn a recursive formula, and tomorrow we learn an explicit formula. We will learn this again in geometry for 2. So a recursive formula to me is kind of, I won't say stupid, but I don't like it. I've never used it. I use an explicit formula big time, but a recursive formula just says how do you get your next term. Okay, an explicit formula you would use to say what is the 100 term? Because do you want to count out to 100 terms? No, like if I give you the first three and then I tell you to find the 100th term, want to add something that many more times? No, that's an explicit formula. So a recursive formula, it just kind of tells you how do you get to your next term. So let me see how they write it. I'm going to use, I think, our geometry one. I'm trying to look and see. That's what I want to do. Okay, this is what it's going to look like. This looks crazy. Lots of letters. What in the world does all this mean? It looks very confusing. Okay, I'm gonna highlight the only thing that you're gonna change for your answer. Okay, let me make sure. Yeah. Right there. That's the only thing that you change for your answer. And you always also put this, and let me explain what all this means. Looks like a little foreign language, doesn't it? All right. This just means I'm going to write this as my answer every time. It says I'm looking for. Okay. You take the previous number. That's what n minus 1 means. Does that make sense? Kind of, maybe. If not, that's okay. All right. So you take the previous number, the one right before it, and add whatever you were adding each time. Okay? And that's it. That's all you would fill. This right here means what's the first term y'all start with? So let me give y'all an example. I'll do one of theirs. They do 70, 77, 80. They go from 70 to 7 to 84. Okay. They give you some more. To 91. So my answer so far, I'm going to write the same thing. What did I highlight? That's the only thing I'm changing my answer here that I know. But it just means my answer, whatever one I'm looking for, I take the previous and I add, well, I don't know, what am I adding every time? 7. So that's what I'm going to change. 7. That is, and yes, I will put the formula up on the board. Okay, I think I even put the formula on the board. 7. Because hold on, now we're getting to the first term. We're getting to the 70 in just a second. But do y'all see? This stands for what's your common difference. If I was subtracting 7, then what would I put right here? Minus 7. But if do you see that I'm adding 7 every time? So I'm putting a plus 7. The other part we have to fill out is what's the first term. So what's the first term? 70. So I am going to use that 70. That's what that means. It means, hey, what do I start with? 70. Okay? What would you to find the 8th term? We learned this stuff for tomorrow yet. What would you do to find the 8th term? Just add 7 several times until you get to it. Okay? So anyway, yeah, let's go ahead and do that. Do that just so we finish the problem. So now I said, okay, let's find that term. And they may write that like this. Like they may say, hey, what's the 8th term? Oh, I didn't realize that was right there. So if it said that, I would take, look, watch me just do this. I'll take my 70. Well, no, I don't have to do that. I have to take my and add 7. What do I get next? 98. This is confusing writing because that's not on my paper. 98. Okay, now I can. Then plus 7 again, and that's 105. 5 plus 7 again. 112. And don't I have one more to go to? Plus 7 again, and so my answer is 119. So it might ask something like that. Let's do another one. Okay. You get the hang of it. So if I found the 8th term, that's the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. That is the 8th term. So I just added 7 until I got. So again, let me erase what's on the board. Another one. I'm gonna write my again. Let me just read it. This would be what's written on the board for go by, and you just have to know that's what I change, and then you have to find your first. So what if they have the little sequence? Let's see. I don't want that one. 3, 9, 15, 21. They say write the recursive form, and what's the ninth term? So how would I write the recursive formula? I just write everything out at the beginning. And again, I know this is silly. We don't really use a recursive. So I write that just like it is. That's the term I'm looking for. This is the previous term. And what am I adding every time? 6. So I put right here plus 6. And again, what if I was subtracting 6 every time? What would I put here? Minus 6. Okay? Then what's our first term? 3. That's what we started at. 3. So that's the formula, and include your first term. That all goes together. Now how would you find the ninth term? You would have to add 6 until we have enough terms. So what's 21 plus 6? 27 plus 33 plus 6. 39 plus 6. 45 plus 6. Did I? 1, 2, 3, 4, 5, 6, 7, 9. No, that's just right. So my ninth term is 51. So the ninth term is 51. Or they might write it like this. That's all that. Hey, the first term is 3. The ninth term is 51. How do we feel about this? Not too bad. Usually it's awful. So y'all handled it very well. Let's see. Don't know that I have a sheet for you. I am going to pause it. Stop this video.